Hi, I'm Kyle O'Rourke, creator of the Drone Zoom interface board. The Drone Zoom allows you to easily interface optical zoom cameras to a quadcopter's flight controller or an RC receiver. The Drone Zoom's new version coming out today, the 1.2, has many new features, and I thought that it would be relevant to talk about them for a minute. So on to the new features. On the back of the board, you'll notice that there is a solder jumper between two labels, Video Tran and Receiver. This is a selector that allows you to pick where the 5 volts that powers the board comes from. You can pick either the 5 volts out that comes from most FPV transmitters or the 5 volts out that comes from your servo connection from the RC receiver or flight controller. We ship it with the RC receiver and flight controller connected natively. If you do decide to change it, make sure not to connect both sides to the middle jumper or to each other, as this can cause lots of problems for both your receiver and the FPV transmitter. On the front side of the board, you'll notice that the biggest change is the pinout. The board's pinout now consists of 2 sides, one for input and one for output. I designed it so that the board can plug directly into your FPV transmitter and act as sort of an intermediary between your battery and the RC receiver. The 2 LEDs are for status. The red LED indicates that 5 volts is going to the board. If the red LED doesn't light up or it looks as if it's been burnt out, check your connections and make sure that you didn't plug the battery into the servo port. The green or sometimes blue LED is for status. If it's fading on or off, that means that the board is looking for a PWM signal. Once a connection is found, the LED will blink rapidly. This indicates that the board is receiving a PWM signal and that it is currently verifying the signal. This prevents it from calibrating to noise or other random signals that might appear when you power up your system. Once verified, the green LED should turn off completely and only turn back on when you send a command from your transmitter or press the push button. The board has a ranged input, meaning that to zoom in, you move your joystick forward, and to zoom out, you move it backwards. To stop moving, you move your joystick back to the center. If your controls are inverted, press the front button on the Drone Zoom board, and this will invert the controls and save it in memory. The 2x3 pin header on the board is used during programming. You can leave it be, or if you want, clip off the leads. To mount the board to the camera, I use double-sided 3M tape, the foamy kind. Well, there you have it, the new Drone Zoom version 1.2. If you like it or hate it, please leave a comment and let me know what you think. You can also visit my website, kyleo'rourke.com, for more information. Thanks for watching.